Hello and welcome back. In this video we'll be discussing finding an equation of a line that has two variables and is linear. There's also a PDF with notes on it. First thing I'm going to talk about is a couple of different forms of equations. We've already seen standard form, ax plus by equals c, where a, b, and c must be integer values. A and b cannot both be 0. The next one is slope-intercept form. You've probably seen this one before. It's y equals mx plus b, where m is the slope, and slope can be a fraction, and b is the y-intercept. That could be a fraction also, but it's easier to graph when it's not. Point-slope form, where you have a point, x1, y1, which those values go here and here. That's a point. And of course you still have m, which is the slope. So you have a point and a slope. First example, find an equation in standard form, so this is the form that we want, of the line that contains this point and has this slope. So if it has that point and that slope, we want to use point slope. So the slope goes here and the point values go here and here. So we're going to write out the equation y minus, and in place of y sub 1, we're going to take -3, put it in there. And in place of m, we're going to use -2 fifths, put our parentheses, and we're going to bring our x down, minus, and in place of this x, we're going to put 4. So put a 4 there. And we're going to put it in standard form. Don't forget, standard form. So what I want to do first is clear my fraction. So I'm going to multiply everything by 5. What I might want to do here is call this plus plus, because minus and negative is really plus a positive. So I'm going to times everything by 5, times by 5, times by 5. So 5 times y is 5y. 5 times the positive 3 is 15. And I still have a -2 and x minus 4 on the inside. Now I still have to distribute this 2, so -2x plus 4 when I distribute. I have a 5y plus 15 on this side. Now standard form looks like this, ax plus by equals c, where a, b, and c have to be integer values. That's why I got rid of this fraction with the 5. But I have to have x and y on the same side together, and c, which is all of our constant values, goes on the other side. So basically I need to move this x to this side and the 15 to this side. So when I move the x over, I get a positive 2x plus the 5y that was already there. And when I move the 15 over, I'm going to minus 15 from the 4 that's already there, and that's going to leave me with a -9. So my equation would be 2x plus 5y is equal to -9. So all that multi-step equation and rewriting equations is now going to be used heavily here. Next example, find an equation in standard form again, but of the line that contains the points 1, -2, and 5, 1. Well, I have 2 points, which means I can use a point and I can use a slope, only I have to actually calculate my slope. So slope is going to equal y2 minus y1 over x2 minus x1. So I have to actually calculate slope here. So I'm going to substitute in some points. So let's call this point 2 and this point 1. So this would be 1 minus a -2 for my y, change in y, over my change in x is going to be 5 minus 1. That's my change in x. And that's going to give me, this is a positive there, that's going to give me 3 over 4. So I have a slope of 3/4. Alright, so what goes in place of m is 3 over 4. All I got to do now is choose a point. I can either use the first point or the second point to substitute in, and I'm going to go ahead and do both points. I'm going to use the first point here first, 1, -2. So y minus -2 equals, and in place of m, I'm putting 3/4 for both equations. 3/4, then I've got an x minus, and then this other x over here is going to be a 1. Okay, so the first thing I want to do is clear my fraction. So I get a 4y, and this is a plus 2, so 4 times 2 is going to give me a positive 8. Remember, what I'm doing here is timesing by 4. And I still have a 3 times x minus 1 on the right hand side. So I distribute here and here. Then I'm going to go ahead and distribute my 3. So 4 y plus 8 is going to equal, distribute here, 3x, distribute here, negative 3. Now I need to move the x over here and the 8 over here to get it in standard form. So when I move the x over, it becomes a negative 3x plus 4y. When I move the 8 over, I'm going to minus 8 from this side, which will give me a negative 11. And that right there is the solution. So we do have this as our equation. So we're going to write that and bring it over here, because I'm going to show you how to solve this with the other point. People will ask, well, what if you chose this point over here instead? We're going to do the same thing. For this problem, though, we're going to use the second point. So y minus, and we have a 1 for the first y. Slope is still 3/4. X minus, and then I have a 5 for my other x. So that's this point right here. So first thing I'm going to do is still get rid of the denominator 4. So I'm going to times by 4 times by 4. So I will have a 4y minus 4 on this side, and then a 3 times x minus 5 here. I still want to distribute my 3, so 4y minus 4 is equal to 3x minus 15. And I want to move my 3x this way and my minus 4 that way. So when I move the 3x over, I get a negative 3x. I already had a 4y out in front, equals, but when I move this 4y over, it becomes a plus 4. So negative 15 plus 4 is going to leave me with a negative 11. And you can see that this equation here still equals the other equation that we got in standard form. For our next example, we're going to find an equation in standard form again, but of the line that has a slope of negative 2 and a y-intercept of 4/3. So we're going to use the slope-intercept form. So slope goes here and the y-intercept goes there. This is kind of an easy form. So I got y is equal to m, which is negative 2, times x, and the y-intercept is b, so plus 4/3. Now remember, standard form does not have any fractions, so I'm going to first multiply everything by 3 to clear the fractions. So I have a 3y here times 3 here gives me a negative 6x times 3 here leaves me with a positive 4. All I got to do now is move my 6x over to get it in standard form. So 6x plus 3y is going to equal positive 4. And there's our equation in standard form. Okay, there are some scenarios in which you'll have lines that are parallel to each other and perpendicular. And here's what we're talking about by what we mean by parallel lines. Parallel lines do not intersect in the same plane. They also have, you might want to boldface this, the same slope with different y-intercepts. They have to have the same slope with a different y-intercept. That's the only way that they can be parallel to each other. They have the same rise and run, so they have a up 1 over 2, up 1 over 2, same slope as each other, and their y-intercepts are at different locations. If they were in the same slope and the same location, they would be the same line. What about perpendicular lines? Well, they intersect at 90 degrees, meaning there is a 90-degree angle created right here. They have negative reciprocal slopes. That means slopes that are flipped over and the signs are changed. The y-intercepts can be any real number value that they want. They can cross at the same location. They don't have to have the same location, but I went ahead and used it on this one as an example. Now let's go ahead and calculate the slope of the red line. So the slope of the red line is going to be, if I start here, up 1 over 2, so up 1 over 2, rise over run is 1/2. So let's do the slope of the blue one. We'll start at the same point right here, so that's down 2, which is negative 2, and to the right 1 to land on that, which is positive 1. And you can see that we actually have two slopes here that are negative reciprocals, or opposite signs, but reciprocals of each other. So the reciprocal of 1/2 is 2, but the sign would have to change to a negative. So negative reciprocal of 1/2 is negative 2 over 1, or just negative 2. For this example, we are given a point 4, 1, and a line L. So line L is this equation right here. We want to find an equation in standard form that is parallel to this line, but it also goes through this point. So the first thing we've got to figure out is, what is the slope of this line? Well, the slope of the line is actually kind of easy to calculate. If you remember back to the previous video, when you have an equation that's written in standard form, ax plus by equals c, slope is equal to the opposite of a over b. And a, of course, is the coefficient of x, and b is the coefficient of y. So the slope of this line up here is equal to the opposite of a, which is 2, so that's negative 2, over b, which is 5. So the slope of this line is negative 2/5. So the slope of the line that's going to be parallel will have exactly the same slope as that one. So I can take this negative 2/5 and drop it in my equation, negative 2/5. Put my x in there, my minus, put my y in my minus. All I got to do now is put my y1 and my x1, and that comes from 4, 1, the y value being 1, the x value being 4. Now before I distribute, I want to get rid of this 5. I want to clear my fraction, so I'm going to times by 5 on both sides. Times by 5. 5 times y is 5y. 5 times negative 1 is negative 5. I still have a negative 2 times x minus 4. And then I'm going to go ahead and distribute my negative 2. So 5y minus 5 is equal to negative 2 when I distribute x. Negative 2 times negative 4 is positive 8. To put this in standard form, I got to move the negative 2 over this way with the x, so it becomes a positive 2x. I still have a positive 5y over there, but I also need to move the 5 this way, so I'm going to add 5 to the 8, and I end up with a 13. So in standard form, the line that's parallel to it is 2x plus 5y is equal to 13. For this example, we have the same scenario. We have the 0.41 and the line that is represented by 2x plus 5y equals negative 10. However, we want to find the equation in standard form of the line that is perpendicular to L but goes through the same point. Well, we already know what the slope of this line is. We calculated it on the previous one, and the slope was right here, negative 2/5. So I know that my slope is equal to negative 2/5. But I'm talking about a perpendicular line. Well, perpendicular line is a negative reciprocal, so the perpendicular slope is going to be positive 5 over 2. So we're not going to use this one for the equation. We're going to use the perpendicular slope, which is 5 over 2. So in place of m, we're going to put 5 over 2, bring down my x minus and my y minus, and I'm going to use the same point for 1. So I have a 1 for y and a 4 for x. In order to calculate this, I want to first clear my fractions. So times by 2, distribute here, I get 2y, distribute here, I get minus 2. And of course, the 2's will cancel out, leaving with 5 times x minus 4. Go ahead and distribute on this side. We get 5x minus 20. And I still have a 2y minus 2 on this side. And for my last step, I'm going to bring my x to this side, which will give me a negative 5x plus the 2y that's already over there. But I'm going to take this minus 2, move to this side as a plus 2, and when I combine these together, that will now be equal to negative 18. So the line that's perpendicular to this line but goes through this point is negative 5x plus 2y is equal to negative 18.